gives it back to the body transcutaneously through the keratinocytes, the ion gates of the keratinocyte cells. It gives it into the body again as a dynamic field, as a field of different signals that are integrated as a language that is already integrated. So not just as sounds or as a phonemes, but as a whole paragraphs, as whole words, as whole, like a movie or like a musical piece. And this is what the cells do. They integrate these signals, and this is what the cells expect in order to function again. They expect these signals to be offered to them, integrated. So this is what this machine does, pretty much. Next, please. You have a question? Any questions so far? You're with me? Everybody's following? Stop me if you don't follow. I don't want to lose you. Okay? It's very important that I don't lose you, because if I lose you, then you're gonna really be lost. Okay, so this is just a diagram of how things work. So you have nonsense or faded protein signals. This is nonsense of faded hormone signals, non-functional neurotransmitters, nonsense faded enzyme signals. All that would lead to cellular collapse, aging, and disease. Again, reduced autophagy. That is the autophagy. You see, it's like a vacuum that cleans up the system. Basically, it eats up all the broken cells and all the proteins there that are denatured, in other words, broken down, that they cannot function anymore. Non-functional antibodies, non-functional ion channels, all of those are going to lead to cellular collapse, aging, and disease. So basically, what reduced autophagy will do is that there will be the defective cells, there will be no degradation of defective cells. It's going to be unable to remove harmful proteins, protecting the cell from diseases. Otherwise, you're going to have all these nonsense signals. Can you imagine a society with policemen that tell you nonsense? Instead of telling you to go to the left, they tell you to go to the right, and you're going to hit the wall. I mean, imagine a society that everything is a nonsense signal, right? It's going to be extremely dangerous to live in such a society. It's the same thing. That's why you need autophagy. You need to remove all these people that are either crazy or they cannot, well, the cells, obviously, that they give the wrong signals. Next, please. Now, this is basically what the communications look like. And what you see here, you basically see an internet. Just like the internet that works to send your emails out, this is what the body does. It's not a linear process. It doesn't go from A to B to C. It goes from A to Z to Z, from Z to C, from C to D. It goes in many, many different places. So that's another complication in trying to create the signals in a technology like this one, because you need to understand how these signals work and they combine together. Now, the result of examining 7,123 proteins, and we looked at protein-to-protein interactions in age versus young subjects, demonstrated that aging is the result of a disorganization in protein-to-protein interactions or communications. So it was a very complex study with a lot of, obviously on proteins, a lot of mathematics and a lot of tedious processes. Next, please. So, do we need needles to administer stem cells? The answer is no, we don't, because all we need is the stem cell to go through the ion gate of the cell. That's all we need. We need to pass the stem cell. You can do that through an injection. It doesn't mean it's going to go into the stem cell. If into the cell, if the gates are closed, it's not going to go into the cell. Here, this is the best way of administering the stem cells, because you're opening the gates and therefore you can pass the signals through. So you can do it. You've heard of needless vaccination, and it's done through voltage. So one way of doing that is you shoot the stem cell with a voltage. The second way is you do it through this technology, which is basically you drive it by electrons through the ion channels that they open up at certain energies that are proprietary. Next, please. So, injecting stem cells has led to a lot of legal problems. And again, I discussed that before. And FDA has a lot of problems with injections in America. So you can apply this, stem cells extracts without needles. And again, this is very, very safe, a very safe manner of doing that. And you can have, obviously, the stem cell extracts, it's protein signals. So what you're doing is you're passing through the cell protein signals that will help the cell kind of revive its own signals that are not working anymore. So what you have here is you have a situation where you send the signals from the device, but you also send the signals from the stem cell extract. So it's twice as many signals. It's far more, it's a much better, basically, it's reinforced. One signal reinforces the other. Next, please. So, again, how does it go through the skin? I have already explained it. It's proprietary energies. It's energies that we had to test. We have to find them, trial and error. It's certain energies, and in these energies, you can basically deliver the signal and the stem cell extract through the ion channel. These energies, next please, I'll explain what these energies are. Next. Okay, so before we talk about that, let's talk about what stem cell extracts you want. There's a lot of them. A lot of them have peptides. You can have stem cell extracts with peptides. Peptides are part of a protein. And now you're going to see what peptides is in the next slides. It's preferred to get a stem cell extract that actually has the protein itself. Why? Because when you put parts of a protein into the skin, then it's like, okay, maybe it will become a protein, maybe it won't become a protein. If in the aged person, it's going to have a lot more trouble becoming a protein than the younger person that does that far more easily. So you're taking a chance, in other words, you're sort of crossing your fingers. You put in the peptides and you say, okay, I'm crossing my fingers, now it's going to become a protein, then the protein is going to give the signal, then the signal is going to revive the signal of the cell. You see, you have like several steps before you really get where you want to get. Instead, it's much preferable to have basically to give a protein. Next, please. So the way it works, okay, it goes from genes, it goes to amino acids, then the amino acids build peptides, then the peptides build proteins, and the proteins are controlled by what we call the chaperone proteins they're doing the folding on the proteins. That's just a little bit of biochemistry so you can understand and you know when you want to look at stem cell extracts which one to choose. So the chaperones are very important because if the protein is not folded, it's useless. Okay, so the protein has to be folded, or don't worry about it. It's just you might as well have the vacuum to clean it out because it's just completely useless. And if it gives a signal, it's going to be a nonsense signal. Next, please. Now this is just a picture. This is a gene, and this is how we. Next one. Okay, this is 2 amino acids, and this is how they create the peptide bond, basically. So you see it goes from amino acid. This is just biochemistry. Next, please. And this is amino acids, the peptide, and this is the protein. So you can see it's a far more complex than a peptide is far basically. A protein is far more complex, and of course the amino acid is it's like little bits that nobody has connected them together. So this is sort of the beads, this is part of a necklace, and this is the actual necklace, if you want to kind of have that comparison. Next please. And this is how the proteins are. This is a protein process, and how you see how they are folded. This is a functional protein if it's folded. Next please. And this is what denaturation is. This guy has no signal, or if he has a signal, you don't want to listen to it because it's nonsense. Okay? So denaturation, and a lot of radio frequency, by the way, does denature proteins. So at that level, there is a damaging process there. And again, what you can do by using this device is you can heal that part, and you can sort of avoid problems that could occur in the future from such a technology. So this is a normal protein, this is a denatured protein. And it can be renatured, it can start being folded again if you have the correct signals. So that's another thing that we're trying to kind of work on this technology to renature denatured proteins. Next please. This is again another problem that can happen with proteins. This is an aggregated protein. This is a big problem. An unfolded aggregated protein is a big problem because it's not going to have a signal, or it's going to have a nonsense signal. Again, basically, this is what you want. And this is what the chaperone proteins do, the folded proteins. Well, once it starts unfolding, forget it. It's not good. It's a bad thing for you. You might as well get rid of it. Next, please. So peptides and proteins are made of amino acids. Peptides are one or more amino acids. Proteins are composed of one or more polypeptides, and it goes on like that. Next, please. Everybody understands this? Are you all clear? Yes? Okay. Now, chaperones are very important because the chaperones will assist in the folding of the proteins. Remember, the folding determines protein function, so that's very important. Chaperones are very important. Chaperones prevent proteins from incorrect folding and again becoming nonsense. So tendency for proteins to aggregate increases under trauma or any type of biological stress. That is very important. So now, does anybody understand why we're saying if you utilize this technology after a laser and radio frequency that will create trauma, it will enhance your results? Can you understand now why? Because the proteins will start aggregate as a result of the trauma. Here, because you're going to be healing the trauma, you're going to create a renaturaling of the proteins. So you're going to sort of start healing the trauma, and you're going to avoid this aggregation, which will create a lot of nonsense signals in the long run. So that's something that I'm sure you have not come across. That's a very important thing that you need to keep in mind from now on, that tendency for proteins, a tendency for proteins to aggregate. Aggregate means becoming useless during stress. That's why when somebody is under stress, what happens? They look more aged, right? Why? Because there is a tendency for proteins to aggregate during stress or trauma. And if you go for a vacation and you sit there and you do nothing and you just go by the beach, wherever, then you are looking much healthier. Why? Again, because you don't have the stress that will aggregate your proteins. The whole health depends on the proteins being healthy and communicating properly. Our entire health, our entire, anti-aging efforts rely on our proteins functioning properly, because the proteins are the brains of the cell. If you destroy the brain of the cell, then the cell cannot function. Like if somebody destroyed your brain, what would you do? You wouldn't be able to function. So it's a very, very important principle that you always need to remember. And this is what we said, you do a technology like this that does the healing, so therefore you're going to have increased effectiveness on your results. Why? Because you help the proteins reestablish their functioning. Next, please. So let's ask some questions. The presence of which will be the most useful after laser treatments for repair and rejuvenation? Is it going to be peptides, proteins, or chaperone? We can answer that. Huh? Chaperone, very good, excellent. The gentleman here on the third row, fantastic with the glasses. Excellent. How will chaperones be useful to protein aggregation caused due to resulting trauma? So the protein is going to unfold, then it's going to start aggregating, meaning it's going to be like junk, just like your clothes, they're all wrinkled and they're like thrown in some corner kind of thing. So how the chaperones can help? Because they're going to start folding the clothes, like when you iron the clothes again and you fold it. So they're going to re-nature the proteins. That's what the chaperones are doing. So so if you have, say, stem cell extracts with chaperones, that's going to be the most preferable stem cell extract, but that's going to be the most expensive ones because obviously you can't have those that easily. So which will be more useful in dealing with protein denaturing and aggregation? The stem cells with peptides or stem cells with chaperone proteins? You all know, yeah, exactly. You all know the answer to that one. Good. Okay, so basically you want stem cell extracts that have chaperones because they're going to start folding all those unfolded proteins. So instead of, because you see, yeah, you can get rid of them with autophagy, you can clean them out, but then you don't have enough. Like if you're old, you have so many, you know. You're old like me, for example, you need a lot more proteins. You cannot just throw away your proteins there easily. You know, you have to be more economical in terms of proteins. So you want the chaperones to refold the proteins. So that's why that type of stem cell will be much preferable. Next, please. So we have here trauma leads to DNA denaturing, it leads to nonsense protein formation, it leads also to free radicals, and that also leads to protein denaturing, and then it leads to aging. Nonsense protein formation will lead to aging. Now, we have the electrons from the IELLIOS and the signals together, right? And what they do is the electrons that come from this technology get the free radicals into stable molecules. How do they do that? Okay, this is very, very important principle. You cannot go back in time as a whole person, am I right? Can you take a time machine and go back in time? Do you know if anybody has done that other than the movies? No. Okay, you cannot go back in time because as a whole person, you're more than the sum of your parts, okay? But molecular mechanisms go back in time continuously. So a free radical is a stable molecule minus one electron. If that free radical gets an electron back, it becomes a stable molecule. It goes back in time. If I cut my arm, forget it, I'm not going to get another arm, that's it. I lost it. But a free radical lost one electron, it's fine. I mean, or a stable molecule lost one electron, becomes free radical, then you give another electron, it goes back to being a stable molecule. So back and forth in time, no problem. They can reverse time, no problem. Molecular mechanisms can, but not whole entities. So it also, I'm going to talk about that a little bit more later. So it also, you can turn nonsense signals into meaningful signals by renaturing the proteins, again, like we explained, right? And that's what signaling does. It gives the signal of how that can happen. And it amplifies the faded protein signals. So then you have, of course, some DNA repair. Why do we say DNA repair from free radicals? Okay, what we have seen is that DNA is damaged because of the free radicals. It just breaks out the DNA. And when you give electrons, what is an antioxidant? Why antioxidants work? Antioxidants donate electrons to free radicals without becoming free radicals themselves. So they come in with a lot of electrons, like vitamin C, whatever, and donate electrons. That's why you say, I'm going to do a vitamin C injection. It's going to be good for anti-aging because it donates electrons to the free radicals. Therefore, it can repair somewhat the DNA. So DNA can repair itself from electrons because the free radicals become stable molecules. Everybody understands that, yeah? Okay. So you have a meaningful protein production, and of course you have the chaperones that can have refold the denatured proteins. Therefore, you have the anti-aging process. Next, please. So okay, this is what I was talking about, okay? So a stable molecule and an unstable molecule, you lose one radical, and this is basically the free radical, goes and grabs an electron, because that's what free radicals do, they grab an electron. They try to make themselves into stable molecules, but they don't always succeed. So they grab an electron, now this one is going to become a free radical, and this one is going to take from this, the electron from that, so that's going to become a free radical. So this whole thing is going to be absolutely damaged. And what all it is that if it had 2, 4, 6, 8, it would be a stable molecule. Now it only has 3, so it's a free radical. But if it had 4, it would be a stable molecule because a stable molecule is an even number of electrons. A free radical is an odd number of electrons. It's as simple as that. So you can go back and forth at any time. This is the electron donation. So it donates an electron, so the free radical can become a stable molecule. Next, please. Okay, so now let's see how does the IELLIOS energy carry the signals into the keratinocytes. Its keratinocytes are the cells of the skin. Okay, well, it's cells all over them. You know, in the skin, under the skin, over the skin. There's different types of cells. Keratinocytes happen to be the ones at the very top of the cell. So how does it do it? Do you see how this is an ion gate? This is a cell, and this is the ion gate. And the signals, this can be nutrients, they can be oxygen, they can be signals, they can be stem cell extracts, they can be anything you want, okay? This one, at certain energies, this gate would just open, like abracadabra kind of thing. The same kind of concept, you know, with the genie. And when the gate opens, then all these elements can go in. It can be nutrients, it can be stem cell extracts, whatever. Next, please. Now, this is another way. This is again the cell, and this is an ion channel. So it's just another diagram so you can see how it basically works. So this is the stem cell. The cell, not the stem cell. And this is how the signals or the stem cell extracts will go through the ion channels to enter the cell. As you can see, there is an excretion. So whatever the cell will not accept, it will be excreted, because otherwise you would have damaging agents getting into the cell and staying there. So the signal that you put in there has to be the signal that the cell understands as its own signal. If it's not the same signal, it will be excreted. The way if you go to a country that you don't speak the language and you listen to people talk the language around you, what do? You tune out, right? You just do, how do you call it, tune off? You just don't listen. It doesn't matter what they say because you cannot understand them. So it's the same thing. It has to be a signal, and that leads to another major complication in creating this technology. You have to have the signals that the proteins are transmitting. Otherwise, you're not going to be able to do anything. Next, please. Okay, so this is basically how the signals can come from the epidermis to the dermis to the subcutaneous tissue all the way to the muscle. Why? Because basically it's the same signal will keep opening the doors, the little doors, one after another.